Bismillahirrahmanirrahim. In today's lecture, we will talk about polyacids. This lecture is relevant to inorganic chemistry. So, what are the polyacids? These are basically weak acids formed from the amphoteric metals of the group number 5b and 6b, like chromium and molybdenum. Of the periodic classification are characterized by the ease with which they condense to form anions containing several molecules of acid anhydride. So, if we talk about the types of polyacids, there are mainly two types of polyacids: isopolyacids and heteropolyacids. Polyacids that contain only one type of acid anhydride, for example, polychromic acid. These are called as isopolyacids, and polyacids that contain more than one type of anhydride. These are called as heteropolyacids. For instance, polymolybdophosphoric acid. Here we have its formula. So we can say that, in other words, isopolyacids contain only one metal along with hydrogen and oxygen, while heteropolyacids contain two elements other than hydrogen and oxygen, right? So if we talk about isopolyacids in detail, these are formed if the oxygen atoms in any oxyacids are replaced by the radicals of the same acid. For instance, introduction of one or more chromate 3 radicals in H2CrO4 acid gives rise to various acids like H2CrO3.CrO4, H2CrO2.2CrO4, and H2CrO.3CrO4. Isopolyacids may be defined in another way, in which these are derived from a single acid by the elimination of water from more molecules of the same acid. So here you can see that isopolyacid can be derived from a single acid by the elimination of water, right? The most important polyacids are isopolymolybdate, isopolytungstate, and isopolymolybdates. So, what are isopolymolybdates? First of all, we will discuss dipolymolybdate. If we talk about the composition, we can see R2O.2MOO3.NH2O. These are formed when pH of sodium molybdate solution is adjusted 6, right? On crystallization, dipolymolybdate crystallize out. Second of its type is parapolymolybdate. We can also call it as heptapolymolybdate. Its formula is MO7 6 minus 24. These are formed when pH of sodium molybdate solution is adjusted to 4.5, and on crystallization, paramolybdate are crystallized out, and these are the most stable polymolybdates, right? And then we have trimolybdate. Its composition is R2O.3MOO3.NH2O. These are formed by crystallizing parapolymolybdate in the presence of acetic acid. Then we have tetramolybdate. So its composition is R2O.4MOO3.NH2O. It is prepared by treating concentrated solution of alkali molybdate with 1.5 moles of HCl. And then we have octamolybdate. Its composition is R2O.8MOO3.NH2O, and it is prepared by treating concentrated solution of alkali molybdate with 1.75 moles of HCl per mole. So from the above type, it is evident that these are obtained at various pH of alkali molybdate. Their formation can be explained as MOO4 minus is stable at high pH. The sodium and ammonium molybdates are quite stable, right? At pH 4, pH between 4 and 5, MO7 or 24 6 minus paramolybdate is in equilibrium with simple molybdate ion MOO42 minus. And in more acidic solutions, octamolybdate ion like MO 8 26 4 minus is produced. So it is likely that higher polymers are formed. So here we have a chemical reaction. We can see that normal uh, molybdate, normal molybdate on pH 0 is converted into paramolybdate, and at pH between 1.5 and 2.9 it is converted into octamolybdate, MO8 oxygen 26, and then at pH less than 1 it is converted into hydrated oxide. So now we'll move towards isopoly tungstate. We have discussed about polymolybdates in detail. Now we will discuss about isopoly tungstate. Many tungstates are of metal have been described differing R2O ratio WO3. So you know W is the symbol of tungsten. So here we also have some types. These are normal tungstates. Their general formula is MmWO4 whole power n. For instance, we can see Na2WO4, Na2W2O7. So we have these examples of these tungstate. So sodium tungstate is prepared by dissolving tungsten oxide in sodium hydroxide solution and crystallizing solution. And sodium tungstate is water soluble, but other than alkali metal and magnesium tungstates, remaining tungstates are insoluble, right? And then if we talk about Na2W2O7, it is prepared by fusing the oxide in the correct proportions, right? And this ion doesn't exist in solution. Next, we have paratungstate. For example, here we have an example of paratungstate. It is prepared by HCl to boiling solution of sodium tungstate, sodium paratungstate out on cooling, right? Then we have metatungstate. For example, here we have an example of metatungstate. It is prepared by boiling solution of normal tungstate with tungstic acid. Then we can say that alkali metatungstates are more soluble than normal metatungstates. Now we will discuss about isopolyanions of niobium and tantalum. Niobate and tantalate isopolyanions can be obtained by fusing the oxides in an excess of alkali hydroxide or carbonate and dissolving the metals in water. The solutions are stable only at higher pH, and precipitation occurs below pH round about equal to 7 for niobates and almost equal to 10 for tantalates. So here I have drawn a rough structure of this ion, right? This is MO6O19 8 minus ion. So if we talk about M, so M may be equal to niobium or tantalate. And please correct it, this is not molybdenum, this is M. Here M can be either niobate or tantalate, right? So central oxygen atom is shared by all 6 octahedra, right? So you can see I have drawn a rough diagram here. So these were some details about isopolyacids. Now we will discuss about heteropolyacids, right? So what are heteropolyacids? These are obtained by the union of varying number of acid and hydride molecules like these three. And you can see tungsten oxide, molybdenum oxide, vanadium pentoxide with some other acid which furnish the central atom of central ion whole complex anion. Salts of polyacids are obtained by acidifying this solution to an appropriate hydrogen ion concentration. Different types of heteropolyanions are formed by taking different ratios of acid and hydride molecules, and such acids which could furnish central atom of central ion. For instance, heteropoly molybdate and tungstates are produced when alkaline solution of polymolybdate or tungstate are acidified in the presence of these ions, right? We can see ions of phosphate and some other ions, right? So here we have some of the chemical reactions. Heteropoly acids are generally extracted from the aqueous solutions by ethers and esters. Purification of these materials is usually done by crystallization from water and organic solvents. Wherever heteropoly acids are prepared, certain precautions should be kept in mind. These precautions are exact quantities of acid and hydride molecules, and the acid which furnish central atom of central line must be taken. Exact pH must be maintained. Equilibrium has to be established, which is indicated by the fact that pH remains constant throughout the reaction. Most of the heteropolyacids have to be prepared at room temperature because at high temperature, evaporation and concentration cause hydrolysis and change the pH of the solution. So, preparation of heteropolyacids belonging to unsaturated series is very difficult. However, these can be obtained by the decomposition of coordinated compounds of hydrolytic reaction with hydroxide ions. So now we will discuss some of the properties of heteropolyacids and its salts. Generally, heteropolyacids are soluble in water and ether. Heteropolymolybdates and tungstates of small alkali metal ions are water soluble, whereas large metal ions are insoluble in water. For instance, heteropolyacids of lead, barium, these are insoluble, right? Heteropolyacids are generally attacked by hydroxide ions. These are completely decomposed by strong alkalis, right? Here you can see the example of such a reaction, right? Heteropolyacids exhibit isomorphism. In these compound, MO2O7 can replace tungsten oxide and vice versa without bringing any change in crystalline form. Examples showing isomorphism are these two chemical reactions. These are showing some examples of isomorphism. Isomorphism, right? The heteropoly acids show very high basicity, but maximum permitted basicity is never reached. These acids form insoluble precipitates with many complex organic compounds. So now we have a detailed overview of these polyacids, isopolyacids, heteropolyacids, and properties. So first of all, isopolyacids. If we talk about isopolyacids, so we had dimolybdate R2O dot 2 MOO3 dot NH2, parapolymolybdate MO7 O24 6 minus, trimolybdate R2O 3MOO3 dot NH2, tetramolybdate R2O 4MOO3 dot NH2, octapolymolybdate R2O 8MOO3 dot NH2. Then we have isopolyltungstate. So there we had normal tungstates like this, sodium tungstate, paratungstate like this, and metatungstate like this. Then we have isopolyanions of niobium and tantalum, where niobium at pH 7 and tantalum at pH 10. So if we talk about heteropoly acids, So here we have examples of heteropolymolybdate and heteropolytungstate. So here are some reactions regarding these. So I hope that these notes may be proved as some sort of benefit for you. And in the upcoming lecture, we will talk about the polymerization of these compounds. So we will meet in the next lecture. Take care. Subscribe to our channel What's Chemistry and press the bell icon. Thank you.